Welcome back to Raw BM 101, an introduction to bioinstrumentation. In the last lecture, we finished up the topic of transducers, examples and applications of the different types of machinery. In this lecture, we'll be talking about temperature measurement, thermoresistors, as well as thermocouples. First, let's talk a little bit about temperature measurement. Everyone has had their temperature measured at least multiple times in their lives, or even yearly. Body temperature is one of the most tightly controlled physiological variables in the human body, and is one of the 4 basic vital signs that are used to assess a patient's health. There are 2 distinct areas where the temperature can be measured routinely and correctly from a patient. The first being the surface of the skin under an armpit, or inside a body cavity, such as the mouth. Both of these are shown below. Thermistors are an instrument that are used in relation to temperatures. They're made of compressed sinistered metal oxides that change with their resistance in regards to temperature. An increased temperature decreases the resistance of the thermistor. So the hotter it is, the less resistance it will have to a current. The size and mass of the thermistor probe have to be small, as shown below, in order to produce the rapid response time to temperature variations. If it was too large, it would take too long for the temperature variation to change the overall resistance of the object. The thermistors are used for a variety of uses, including blood flow measurement, and a pair of matched thermistors can attach to the tip of a catheter, and it can be guided to different locations of the heart to measure blood flow based on the variations of temperature. They can be heated by a coil or flushed with cold saline to measure blood flow rates. When flushed with cold saline, the first sensor gets cooled more than the second because the blood flow warms up the saline that reaches the second sensor. Since the 2 thermistor sensors are separated by a known distance and the temperature and the volume of the saline is controlled, the blood flow can be calculated by reading the outputs of the 2 sensors. When cold saline is used, these thermistors do not require external power. One application of a thermistor is infant warmers, because of the controlled temperature of the environment that the thermistor can provide. Another application is respiratory air temperature monitoring in anesthesia delivery machines, which we discussed before in the transducers module. Next, we'll be talking about thermocouples, the last part of this module. Thermocouples are temperature transducers formed by joining together 2 dissimilar metals. An electromotive force is generated as a result of the 2 different temperatures at the 2 junctions of the dissimilar metals. Because of this function, they are capable of recognizing a temperature difference between the 2 points. However, they cannot measure absolute temperature directly. In order to measure absolute temperature of a measured environment, the temperature of the reference junction must be determined independently and factored into the absolute temperature calculation. In principle, one junction can be maintained at a constant reference temperature, for example, 0 degrees if the reference junction is laced with an insulated ice water bath. For example, 0 degrees if the reference junction is laced with an insulated ice water bath, while the other junction is used to measure the unknown temperature of the environment. The small size, fast response, and rugged design of thermocouple probes make them very attractive for in vivo application.